Good morning, chemistry students. This is Mrs. Krumschreider with your Chapter 7, Day 5 notes. We are going to be doing about half of Chapter 7, Section 3. So today we're going to focus on percent composition. And again, you're still going to want to have your chemistry toolkit index card handy. You're going to want to have your periodic table handy and definitely a calculator handy as well. Okay, as we get started on percent composition. So we're going to start by talking about how we calculate the percent composition of a compound. And we're going to start with the definition of percent composition. So the definition of percent composition is the relative amounts of the elements in a compound. So again, basically, we're talking about the relative amounts, okay? Another way to kind of define percent composition is to say that percent composition is the percent by mass of each element in the compound. And part of the reason you're learning to calculate percent composition is that the percent composition of a compound is always the same for a particular compound. What that means is if we were to calculate the percent composition of water, all water would have that same percent composition. So percent composition is sometimes a way that scientists identify unknown compounds. So percent composition, to figure out the percent by mass of an element in a compound excuse me, is the number of grams of the element divided by the mass in grams of the compound multiplied by 100%. So this is, in words, how you would calculate percent composition. So, in words, to calculate the percent by mass of an element in a compound, you take the number of grams of that element and divide it by the mass in grams of the compound, and then you multiply that all by 100%. In equation forms, okay, the percent by mass of an element is equal to the mass of the element divided by the mass of the compound times 100%. Okay, so in this circumstance, you would use this equation because they've said you have 14 grams of hydrogen and the compound is 18 grams. Okay, and so you would use this equation. However, sometimes you're going to be asked to calculate it given some information. So you could also calculate percent composition using the chemical formula and in which case the subscripts in the formula are used to calculate the mass of each element in 1 mole, and you use molar mass. So remember, you've learned about molar mass already, right? That's the mass in grams per mole of your substance, and to figure out a molar mass, you have to have a chemical formula. So what this looks like in an equation form, okay, is that the percent by mass of an element equals the mass of the element in 1 mole of compound divided by the molar mass of the compound still times 100%. Okay, and we're going to look at an example problem here of each of these. Okay, so these are your equations. Now remember, when I ask you to do problems, I want to see an equation. And so when I ask for an equation, I mean I want to see either this equation or this equation written out in words. So we are going to fit 2 problems in the space that you have. Okay, so problem number 1. Okay, when a 13.60 gram sample of compound containing only magnesium and oxygen is decomposed or broken down, 5.40 grams of oxygen is obtained. What is the percent composition of this compound? So again, I still like to summarize the information that they've given us. Okay, so in this problem, they have given us that the mass of the compound is equal to 13.60 grams. And they've told me the mass of oxygen is equal to 5.40 grams. So, how would I figure out the mass of the magnesium? Well, if I know the mass of the compound and I know the mass of one of the elements in the compound, and I know that the only other element in the compound is magnesium, I can figure out the mass of magnesium by finding the difference between these, right? So the mass of magnesium is going to be 13.60 minus 5.40, which is 8.20 grams. Now, in terms of significant figures, remember we're adding and subtracting here, so it's position, and we have numbers in our hundredths place, and so our answer has to have a number in our hundredths place. So then, to figure out the percent of oxygen, it's going to be the grams of oxygen over the grams of the compound times 100%. So my grams of oxygen was 5.40 grams. My grams of my compound was 13.60 grams times 100. Now, in terms of significant figures, now I'm multiplying and dividing. So 5.40 has 3 sig figs. 13.60 has 4. So my answer should have 3 significant figures. So you should get about 39.7% oxygen. Now, I have 2 options for how I calculate the percent of magnesium. Okay? Option 1, I know that 100% is the total, and I can subtract the percentage of oxygen that I have and figure out what percentage of magnesium I have, which should be about 60.3%. Now, the problem with this is, if this answer here is wrong, then this answer here is going to be wrong as well. So I really would caution you away from doing that, but it's your call. I would suggest that you always do option number 2, which is pretty much you're going to repeat the calculation you already did for oxygen, but now for magnesium. So you're going to do your grams of magnesium over the grams of your compound times 100. Again, we figured out the grams of magnesium to be 8.20 grams. The grams of our compound was 13.60 grams times 100. Okay? And again, you should get 60.3% magnesium. So my preference is option 2, because this answer here, right, and this answer here should add up to 100%. And if you get the second one and the 2 of them together don't add up to 100%, that's your clue that you have probably done something wrong and you need to double check or redo your calculations. So that's that example where we're using that first equation where we're using our grams of our element divided by our grams of our compound times 100% to calculate the percent composition. For our second problem, okay, we're going to do it kind of using that second equation. So our problem number 2 here is propane, which is C3H8. Okay. The fuel commonly used in gas grills is one of the compounds obtained from petroleum. We want to calculate the percent composition of propane. Okay, so here notice we have no mass data, right? So here we're going to have to use that second option where we're calculating our molar mass and using that information. When you have a problem like this is one time when it's nice to show your work for molar mass because you're going to need that information. Okay, so we know we have carbon and hydrogen in our compound. there are 3 carbons and 8 hydrogens. And carbon has a mass of 12.011, and hydrogen has a mass of 1.0079, according to the periodic table I'm using. Okay. So I'm going to get 36.033 here and 8.0632 here. Now remember, I'm calculating molar mass, so I'm going to add these two together. And my molar mass of propane is 44.062 grams per mole. Okay, so now I've calculated my molar mass because I need that information. Remember, our equation for this is that the percent of carbon is the grams of carbon in 1 mole divided by the molar mass of the compound times 100%. Now, the reason showing my work is nice is my grams of carbon in 1 mole is this number right here. So that's 36.033 divided by my molar mass, which was the 44. Oops. Times 100. Okay. And again, I would just suggest using 1 decimal place for my answer. So you should get about 81.8% carbon. Now, again, you have 2 options for hydrogen, right? Option 1, I take 100%, I subtract my 81.8%, and I get about 18.2% hydrogen. That's fine and dandy so long as I've calculated my percent carbon correctly. If I haven't, then both answers are going to be wrong. So my suggestion again is to do percent of hydrogen is the grams of hydrogen in 1 mole divided by the molar mass of the compound times 100. Again, I have this number. It's 8.0632. I know my molar mass. And I'm going to get about 18.2% hydrogen. This will be the more common way the problems in this chapter will be. So they're typically not going to give you mass data. They're typically going to expect you to write the formula. Sometimes they're just going to give you the name, so you have to write your formula correctly and then calculate the percent composition. So the last little bit with this, because we've been talking about conversion factors, is using this information that we've just calculated, our percent composition, as a conversion factor. So, okay, you can use percent composition to calculate the number of grams of any element in a specific mass of compound. The idea behind this is that percent means per 100, okay? So when we're talking about percent composition, it's per 100. Therefore, okay, you have a conversion factor. Your conversion factor is your percentage grams of the element over 100 grams of your compound. Or, and again, remember the power of these conversion factors is that I can flip them depending upon where I need my units to be. So if I need my 100 grams of compound or grams of compound to be on the top and my grams of my element to be on the bottom, I can do that. But basically, by saying that you have 100 grams of your compound, then your percentage becomes a mass. So let's take a look at an example problem with that. Calculate the mass of carbon and the mass of hydrogen in 82 grams of propane. Now, we already did some of this problem here, right? If we had not done this already, okay, here, then we would have to do this work. But we've already done it, so we know our percent of carbon and our percent of hydrogen. They're right here. So we know that we have 81.8% carbon and 18.2% hydrogen from the problem that we've already done. Okay, so this was answers from our previous problem. If we hadn't been given that, then we would have to do all this work. Okay, but because we've already done that, we're not going to do it again. So, again, our equation, basically what this is saying is that we have 81.8 grams of carbon in 100 grams of propane. Okay, that means that we can, remember that's what we just said, this conversion factor is if we assume we have 100 grams of our compound, then our percentage becomes a mass. That also means we have the conversion factor that 18.2 grams of hydrogen if we have 100 grams of propane. Now, what is this problem asking us to do? It's saying if we have 82 grams of propane, how many grams of carbon do we have? Let's do that one first. Okay, so we're going to do these the same way we've been doing our conversion factor problems. We're going to start with our given, which is our 82 grams of propane. Grams of propane has to go on the bottom to cross out. We're trying to change it to grams of carbon, which we can because we have the percent composition of carbon. And again, we know that in 100 grams of propane, we would have 81.8 grams of carbon because our percent composition of carbon was 81.8%. So, we put this in our calculator, right? 82 times 81.8 divided by 100. And we should have 3 significant figures, so you should get 67.1 grams of carbon. Now, the second problem here is asking us if we have 82 grams of propane, how many grams of hydrogen do we have? So again, we still start this problem the same way. We're going to start with our 82 grams of propane. Grams of propane have to go on the bottom, so they'll cross out. This time we're trying to calculate our grams of hydrogen, so grams of hydrogen will go on the top. Again, we know our percent composition, so if we assume we have 100 grams of our propane, that means our percentage, which was 18.2, is going to become grams of hydrogen. Again, we should have 3 significant figures. So 82 times 18.2 divided by 100. And you should get about 14.9 grams of hydrogen. So again, this is how I'd like to see work for problems where you're asked to calculate the mass of some element given the grams of a compound. Have a great day. I'll talk to you tomorrow.